the F-35 Lightning II is the most expensive weapons program in human history. Over $1 trillion will be spent across its lifetime. It has been praised as a revolutionary leap in air combat, and criticized as an overpriced, overcomplicated mistake. So why does this aircraft inspire such intense debate? To some, the F-35 represents the future of warfare, a flying computer, a stealthy sensor node, and a battlefield commander in the sky. To others, it is a symbol of government waste, endless delays, and ambitious promises that went too far. But here's the real question. Is the F-35 truly a revolutionary aircraft that reshaped modern combat? Or is it an expensive experiment that failed to live up to expectations? To answer that, we need to look beyond the headlines. Because the F-35 is not designed to fight the wars of the past. It was built for a world where information matters more than speed, where detection is deadlier than dogfighting, and where victory depends on who sees first and shares that information fastest. This is the story of the F-35. Not just as a fighter jet, but as a fundamental shift in how wars are fought. In the past, air combat was about raw performance. Speed, altitude, turning ability. Fighter pilots were judged by their dogfighting skills, and aircraft were measured by how fast they could climb or how tight they could turn. But modern battlefields are different. Today's skies are filled with advanced radar systems, long-range missiles, cyber warfare, and integrated air defense networks that can track and destroy aircraft long before pilots ever see each other. In this environment, the biggest threat is not the enemy fighter you can see. It's the one you never knew was there. This is where the F-35 enters the picture. The F-35 was not designed to be the fastest jet in the sky. It was not designed to win classic dogfights like aircraft from previous generations. Instead, it was designed to do something far more ambitious. To make the battlefield visible. At its core, the F-35 is a stealth aircraft. But stealth alone does not win wars. What truly sets the F-35 apart is its ability to collect, process, and share information. It doesn't just avoid enemy radar. It actively maps the battlespace in real time. Using a network of advanced sensors, the aircraft gathers data from radar, infrared cameras, electronic signals, satellites, and other friendly aircraft. All of this information is fused into a single, clear picture for the pilot. Instead of managing dozens of screens and systems, the pilot sees one unified view of the battlefield. Threats are identified automatically. Targets are prioritized. Friendly forces are tracked. In many ways, the pilot becomes less of a traditional fighter pilot and more of a battlefield commander. And the F-35 doesn't keep this information to itself. One of its most powerful features is its ability to share data across the battlefield. It can transmit targeting information to other aircraft, ships, ground forces, and air defense systems. That means an F-35 might detect an enemy threat, and another platform launches the weapon. The jet becomes a sensor node in a much larger warfighting network. This concept is known as network-centric warfare, and it represents a major shift in military thinking. Instead of individual platforms operating independently, modern forces operate as interconnected systems. Information flows freely. Decisions happen faster. And the side with better situational awareness gains a decisive advantage. The F-35 was designed from the ground up to operate in this environment. But this vision came at a cost. Developing an aircraft that could replace multiple aging fleets, serve the Air Force, Navy, and Marine Corps, and integrate cutting-edge software and stealth technology, was never going to be simple. From the very beginning, the F-35 program faced enormous challenges. Technical setbacks, software delays, budget overruns, political scrutiny. Critics questioned whether it was possible to build one aircraft that could do so many things well. Others argued that the program had become too big to fail. Yet despite these challenges, the F-35 continued to evolve. Today, it is flown by multiple branches of the U.S. military and by allied nations around the world. It has entered real combat operations, and pilots who fly it consistently describe an unprecedented level of situational awareness. Still, controversy remains. Some argue the F-35 is too expensive. Others claim it lacks the dogfighting performance of older jets. And some question whether stealth will remain effective as detection technologies advance. These criticisms are not without merit. But they also miss a crucial point. The F-35 was never meant to fight yesterday's wars. It was built for a future where battles are decided before the first shot is fired, where controlling information is as important as controlling airspace, and where survival depends on being invisible, connected, and informed. Over the next hour, we're going to break down what the F-35 really is, how it was developed, how its stealth actually works, what makes its sensors so powerful, and how it compares to other modern fighter aircraft. We'll look at its strengths, its limitations, and the role it is likely to play in the future of air combat. By the end of this documentary, you'll be able to decide for yourself. Is the F-35 a revolutionary leap forward? Or an overpriced mistake? This is the F-35 Lightning II. And this is how it changed modern warfare. To understand why the F-35 exists, we have to go back to the end of the Cold War. For nearly half a century, global military strategy was shaped by the rivalry between the United States and the Soviet Union. Fighter aircraft were designed for large-scale conflicts between superpowers, where speed, altitude, and raw performance were critical. Jets like the F-15, F-16, and F/A-18 were born in this era, optimized to dominate the skies against Soviet threats that, in many cases, never fully materialized. But when the Cold War ended in the early 1990s, the world changed almost overnight. The Soviet Union collapsed. Defense budgets were reduced. And the likelihood of massive, symmetrical air battles declined. At the same time, new threats began to emerge. Instead of one predictable enemy, the United States now faced a wide range of challenges: regional conflicts, rogue states, advanced surface-to-air missile systems, and the rapid spread of modern military technology. Even smaller nations could now afford sophisticated air defenses capable of denying access to their airspace. This shift forced military planners to rethink everything. The question was no longer how to defeat another superpower's air force. It was how to operate safely in heavily defended airspace against enemies who relied on advanced sensors, missiles, and integrated air defense networks. At the same time, the U.S. military faced another problem. Its aircraft fleet was aging. By the 1990s, many frontline fighters were decades old. Different branches of the military were operating different aircraft, each with its own maintenance systems, training pipelines, and supply chains. This created enormous logistical complexity and rising costs. Something had to change. This was the environment that gave birth to the idea behind the F-35. Rather than developing separate aircraft for each branch of the military, the United States would attempt something unprecedented. One aircraft. Multiple roles. Shared technology. Lower long-term costs. This idea became known as the Joint Strike Fighter program. The goal of the Joint Strike Fighter, or JSF, was ambitious. It aimed to replace several aging aircraft across the U.S. Air Force, Navy, and Marine Corps, including the F-16, A-10, AV-8B Harrier, and older variants of the F/A-18. Instead of building multiple specialized jets, the JSF would be a family of closely related aircraft, sharing a common design but tailored for different missions. In theory, this approach offered enormous advantages. Shared parts would reduce manufacturing costs. Common training would simplify pilot conversion. Unified logistics would lower maintenance expenses. And a single, modern platform could be upgraded over time through software rather than constant redesign. It was an attractive vision. But it was also incredibly risky. No aircraft program had ever attempted to satisfy the needs of three different military branches with one core design. Each branch had its own priorities, mission profiles, and operational environments. The Air Force wanted a lightweight, agile fighter optimized for conventional takeoff and landing. The Navy needed an aircraft capable of surviving the harsh conditions of aircraft carrier operations. And the Marine Corps required something even more challenging, a stealth aircraft capable of short takeoffs and vertical landings. Trying to combine all of these requirements into one airframe would push engineering limits to their breaking point. In the late 1990s, several major defense contractors competed for the Joint Strike Fighter contract. After an extensive evaluation process, Lockheed Martin was selected as the winner in 2001. The aircraft that would eventually become the F-35 was officially underway. From the start, the program promised cutting-edge capabilities. Stealth design, advanced sensors, unprecedented data fusion, and software-driven upgrades that would keep the aircraft relevant for decades. But delivering on those promises proved far more difficult than expected. One of the biggest challenges was complexity. Unlike older fighter jets, the F-35 was as much a software platform as it was a physical aircraft. Millions of lines of code were required to manage sensors, weapons, flight controls, and communications systems. This level of software integration had never been attempted on such a scale in a fighter aircraft. As development progressed, delays began to mount. Software milestones were missed. Testing revealed unexpected problems. And each fix often created new challenges elsewhere in the system. At the same time, costs began to rise. The original promise of affordability became harder to maintain as development stretched on year after year. Critics seized on these overruns as evidence that the program was fundamentally flawed. Media coverage often focused on headlines rather than context. The most expensive jet in history. A program out of control. Too big to fail. Political pressure intensified. Members of Congress questioned whether the F-35 should continue. Some called for scaling back the program. Others suggested canceling it entirely and returning to upgraded versions of older aircraft. But by this point, the F-35 had become deeply embedded in the defense ecosystem. Thousands of jobs depended on it. Multiple allied nations had invested in the program. And billions of dollars had already been spent. Canceling the program would not only waste those investments but also leave the military without a clear replacement plan for its aging aircraft. At the same time, something important was happening behind the scenes. The aircraft itself was improving. Early test pilots began to report that, despite its flaws, the F-35 offered capabilities they had never experienced before. Situational awareness was unmatched. Sensor fusion reduced pilot workload. Stealth allowed access to airspace that would be extremely dangerous for older jets. As testing expanded, the aircraft matured. Production lines became more efficient. Manufacturing defects declined. And unit costs began to fall. Over time, the price of each F-35 dropped significantly, approaching the cost of advanced fourth-generation fighters when adjusted for inflation. Software development also improved. The program transitioned from struggling to deliver basic functionality to rolling out regular upgrades. New capabilities could be added without changing the physical aircraft, extending its usefulness far into the future. International partners played a major role in the program's survival. Countries across Europe, Asia, and the Pacific committed to purchasing the F-35, betting that shared development would give them access to capabilities they could not afford on their own. This international participation strengthened political support and helped distribute costs across multiple nations. By the late 2010s, the narrative began to shift. While criticism never disappeared, the F-35 was no longer seen solely as a troubled development program. It had become an operational aircraft, flying real missions, integrating with Allied forces, and delivering on many of its original promises. The Joint Strike Fighter concept, once seen as overly ambitious, had survived. Not because it was perfect, but because there was no alternative that could deliver the same combination of stealth, sensors, and network integration at scale. The F-35 emerged not as a flawless aircraft, but as a compromise shaped by politics, technology, and strategic necessity. It reflected a world where wars are fought not just with weapons, but with information. Where software matters as much as hardware. And where adaptability is more important than specialization. The history of the F-35 is not just the story of an airplane. It is the story of how modern warfare changed. And in the next section, we'll explore how that change is reflected in the aircraft's design, starting with the stealthy airframe that allows the F-35 to operate where others cannot. When people think about the F-35, the first thing that often comes to mind is stealth. But stealth is not a single feature. It is the result of hundreds of design choices, working together to reduce the aircraft's visibility across multiple detection systems. To understand how the F-35 achieves this, we need to look closely at its airframe and overall design philosophy. At a glance, the F-35 looks different from older fighter jets. Its shape is smooth and angular. Its edges are carefully aligned. And almost nothing about its exterior is accidental. Every curve, angle, and surface was designed with one primary goal in mind: avoid detection. Radar works by emitting radio waves and measuring how much of that energy is reflected back. Traditional aircraft, with exposed weapons, sharp angles, and external fuel tanks, reflect large amounts of radar energy. This makes them easy to detect at long distances. The F-35 takes a very different approach. Its airframe uses carefully aligned edges and flat surfaces that deflect radar waves away from their source instead of reflecting them back. This concept is known as radar evading geometry. Rather than bouncing radar signals straight back to enemy sensors, the F-35 scatters them in multiple directions. The result is a dramatically reduced radar signature. In simple terms, the aircraft appears much smaller on radar than it actually is. This shaping is especially visible in the jet's nose, wing edges, and tail surfaces. Even the canopy and engine inlets are designed to minimize radar reflections. Unlike older fighters, the F-35 avoids right angles and protruding components. Weapons, sensors, and fuel are all integrated into the aircraft's structure. One of the most important stealth features of the F-35 is its internal weapons bays. On older aircraft, missiles and bombs are typically mounted externally under the wings. While this allows for a larger payload, it also dramatically increases radar visibility. The F-35 solves this problem by carrying its weapons internally. By storing missiles and bombs inside the fuselage, the aircraft maintains a clean external shape during stealth operations. This allows it to penetrate heavily defended airspace without exposing itself to radar detection. When stealth is no longer required, the F-35 can carry additional weapons externally. But during the most dangerous phases of a mission, internal carriage gives it a crucial survivability advantage. This trade-off between stealth and payload reflects a key shift in modern air combat. Survival comes first. Firepower comes second. Another critical element of the F-35's stealth design is its use of radar-absorbent materials. These materials, often referred to as RAM, are applied to the aircraft's surface to absorb radar energy rather than reflect it. Think of them as a sponge for radar waves. Instead of bouncing signals back to enemy sensors, these materials convert radar energy into heat, further reducing detection. While this sounds simple in theory, applying radar-absorbent materials to a high-performance aircraft is incredibly challenging. The materials must withstand extreme temperatures, high speeds, and constant environmental exposure. They must remain effective after repeated flights, maintenance cycles, and combat operations. Early stealth aircraft relied on delicate coatings that were difficult to maintain. The F-35 improves on this by integrating stealth materials directly into the aircraft's structure wherever possible. This reduces maintenance demands and improves durability compared to earlier designs. Still, stealth coatings remain one of the most demanding aspects of operating the F-35. Even minor damage to the aircraft's surface can degrade its stealth performance. As a result, maintenance crews require specialized training and facilities to repair and preserve the aircraft's low observable characteristics. This brings us to an important point. Stealth is not invisible. The F-35 is not undetectable. Instead, it is designed to be extremely difficult to track and target, especially at long ranges. By reducing detection distance, the aircraft gains time. Time to identify threats. Time to strike first. And time to leave the area before the enemy can respond. This is why stealth matters more than raw speed in modern combat. In the past, speed was a primary defense. Fighter jets relied on their ability to outrun threats or climb above them. But modern surface-to-air missiles travel at incredible speeds. No fighter jet can outrun a missile once it has been launched. The real advantage lies in avoiding detection altogether. If an enemy radar cannot see you, it cannot target you. If it cannot target you, it cannot shoot you down. The F-35 was designed around this reality. Rather than being the fastest aircraft in the sky, it prioritizes information dominance and survivability. Stealth allows it to operate closer to enemy defenses, gather intelligence, and strike high-value targets with reduced risk. This philosophy represents a major shift in air combat doctrine. Instead of brute force, the F-35 relies on precision, awareness, and timing. Of course, stealth comes with trade-offs. The design compromises required to maintain a low radar signature affect the aircraft's shape and airflow. This can limit top speed and maneuverability compared to some older fighters. Critics often point to these limitations as weaknesses. But this comparison misses the point. The F-35 was never designed to win classic dogfights in open skies. It was designed to avoid them entirely. By seeing first and striking first, the aircraft reduces the need for close-range combat. Another challenge associated with stealth is maintenance. Low observable aircraft require more careful handling than traditional jets. Surface coatings must be inspected regularly. Panels must be aligned precisely. And repairs must preserve the aircraft's stealth characteristics. This increases maintenance time and cost. However, the F-35 represents a significant improvement over earlier stealth aircraft in this area. Its design incorporates lessons learned from platforms like the F-22 and B-2. Stealth features are more durable. Maintenance procedures are more streamlined. And digital diagnostics help crews identify issues more efficiently. Despite this, maintaining stealth remains a demanding task. This has led to ongoing efforts to improve materials, reduce maintenance requirements, and automate inspections. Future upgrades are expected to further simplify sustainment while preserving stealth effectiveness. Visually, the F-35's design tells a clear story. It is not optimized for airshows or dramatic maneuvers. It is optimized for survival in contested airspace. Radar comparison graphics often illustrate this point clearly. When placed next to older fighters, the F-35 appears as a tiny blip on radar displays. In some scenarios, it can approach targets undetected while other aircraft would be tracked from hundreds of kilometers away. CGI diagrams help reveal how radar waves interact with the aircraft's surfaces. Instead of reflecting energy back toward the source, the F-35's geometry redirects it away, reducing the strength of the return signal. These visualizations highlight why stealth is not magic, but engineering. Every design choice represents a compromise. And every compromise serves a strategic purpose. The F-35's airframe and stealth design reflect a world where air superiority is no longer guaranteed, where access to contested airspace determines success or failure, and where the ability to operate unseen can decide the outcome of a conflict before it begins. In the next section, we'll look beyond the aircraft's exterior. We'll explore the sensors and avionics that turn the F-35 into one of the most advanced information platforms ever built. Because stealth allows the F-35 to enter the battlefield, but its sensors are what allow it to dominate it. If stealth allows the F-35 to enter the battlefield unseen, its avionics and sensors are what allow it to dominate that battlefield. This is where the F-35 truly separates itself from every fighter aircraft that came before it. Because at its core, the F-35 is not just a jet. It is a flying command center. Traditional fighter aircraft rely on pilots to manually interpret information from multiple systems. Radar screens, targeting pods, warning receivers, and communication channels all compete for attention. The pilot must mentally piece together this information to understand what is happening around them. In high-stress combat environments, that workload can be overwhelming. The F-35 was designed to solve this problem. Its greatest strength is something known as sensor fusion. Sensor fusion is the process of collecting data from many different sources and combining it into one clear, unified picture. Instead of showing raw data on multiple displays, the F-35 processes information behind the scenes and presents only what the pilot needs to see. In simple terms, the aircraft does the thinking so the pilot can focus on decision-making. Radar data, infrared imagery, electronic signals, friendly and enemy positions. All of this information is fused together into a single, intuitive view of the battlefield. Threats are automatically identified. Targets are prioritized. And important information is highlighted without overwhelming the pilot. This means the pilot spends less time managing systems and more time understanding the fight. At the center of this sensor network is the F-35's primary radar, the AN/APG-81 Active Electronically Scanned Array, or AESA radar. Unlike older mechanically scanned radars, an AESA radar uses thousands of small electronic modules to steer its beam instantly. There are no moving parts. The radar can scan multiple areas at once, track many targets simultaneously, and switch between different modes in a fraction of a second. This gives the F-35 several major advantages. It can detect enemy aircraft at long ranges. It can track multiple targets at the same time. And it can do so while remaining difficult to detect itself. Because the radar beam is electronically controlled, it can operate in ways that reduce the chance of enemy systems detecting it. This makes the F-35 harder to find, even while actively scanning the battlefield. But the radar is only one piece of the puzzle. One of the most unique systems on the F-35 is the Distributed Aperture System, known as DAS. The DAS consists of 6 infrared cameras mounted around the aircraft. Together, they provide full 360-degree coverage of the surrounding airspace. These cameras constantly scan for missile launches, aircraft, and ground threats. If a missile is fired toward the F-35, the system detects the heat signature almost instantly and alerts the pilot. But DAS does more than just provide warnings. It allows the pilot to see in every direction, including directly through the aircraft itself. When paired with the helmet-mounted display, the pilot can look down through the floor of the cockpit and see what is happening beneath the aircraft in real time. Look over your shoulder, and you see behind you. Look down, and you see the ground. This is not science fiction. It is operational reality. This capability dramatically improves situational awareness, especially in complex combat environments where threats can come from any direction. Another critical sensor on the F-35 is the Electro-Optical Targeting System, or EOTS. Mounted on the nose of the aircraft, EOTS combines infrared imaging, laser designation, and long-range target tracking into a single system. It allows the F-35 to identify and track targets at long distances without using radar. This is especially valuable in stealth operations. By relying on passive sensors rather than active radar emissions, the aircraft can observe the battlefield without revealing its position. The pilot can detect targets, confirm identities, and guide weapons with extreme precision. EOTS is used for air-to-ground strikes, intelligence gathering, and close air support missions. It allows the F-35 to operate effectively in both high-intensity conflicts and lower-intensity operations. All of this information flows into one place, the pilot's helmet. The helmet-mounted display system is one of the most advanced pieces of equipment ever fielded in a fighter aircraft. Instead of relying on traditional cockpit displays and a fixed heads-up display, the F-35 projects critical information directly onto the pilot's visor. Speed, altitude, target information, threat warnings, navigation data. Everything moves with the pilot's head. Wherever the pilot looks, the information follows. This creates an unprecedented connection between the pilot and the aircraft. Instead of looking down at instruments, the pilot keeps their eyes outside the cockpit, maintaining awareness of the environment at all times. Combined with the DAS cameras, this gives the pilot what many describe as superhuman situational awareness. But the true power of the F-35's avionics lies in how all these systems work together. Radar data confirms infrared detections. Electronic signals identify enemy emissions. Sensor fusion verifies threats automatically. The aircraft cross-checks information constantly, reducing false alarms and increasing confidence in decision-making. And just as important, the F-35 does not operate alone. It shares this fused data with other aircraft, ships, and ground forces in real time. A target detected by one F-35 can be engaged by another platform entirely. This is why the aircraft is often described as a force multiplier. It does not just increase its own effectiveness. It increases the effectiveness of everything around it. In many missions, the F-35 may never fire a weapon. Instead, it acts as an airborne sensor node, directing other forces and shaping the battle space. This is a fundamental shift in air combat. Older fighters were judged by speed, agility, and weapon load. The F-35 is judged by information dominance. By seeing first, understanding first, and sharing first, it changes how battles unfold. Of course, this level of capability depends heavily on software. The F-35 contains millions of lines of code, constantly updated to improve performance and add new features. Unlike older aircraft that required physical upgrades, many improvements to the F-35 are delivered digitally. This means the aircraft can evolve over time, adapting to new threats without redesigning the airframe. It also means that the F-35's true potential is still unfolding. As sensor technology improves and software becomes more advanced, the aircraft's role as a flying command center will only grow. In the end, the F-35's avionics and sensors redefine what a fighter aircraft can be. It is not just a platform for weapons. It is a platform for information. And in modern warfare, information is the most powerful weapon of all. In the next section, we'll look at how this information advantage translates into real-world capability by examining the different variants of the F-35 and the unique missions each one performs. One of the most unique aspects of the F-35 program is that it is not a single aircraft, but a family of closely related variants. While all F-35s share the same core design philosophy, avionics, and stealth technology, each variant was built to serve a very different mission. This is where the Joint Strike Fighter concept becomes most visible. The F-35A, F-35B, and F-35C exist because the U.S. military operates in very different environments, each with its own operational demands, constraints, and priorities. Trying to meet those needs with a single, identical aircraft would have been impossible. Instead, engineers created three variants that share a common core, but diverge where necessary. Let's break them down. First, the F-35A. The F-35A is the conventional takeoff and landing variant, designed primarily for the United States Air Force. This version most closely resembles a traditional fighter aircraft in how it operates. It takes off from standard runways. It lands like a normal jet. And it is optimized for land-based air operations. Because it does not need to operate from aircraft carriers or perform vertical landings, the F-35A is the lightest and most agile of the three variants. This gives it several advantages. It has the longest range. It can carry the largest internal fuel load relative to its weight. And it offers the best overall performance in terms of acceleration and maneuverability within the F-35 family. The Air Force selected the F-35A as a replacement for multiple aging aircraft, including the F-16 and the A-10 in certain roles. Its mission set includes air superiority, precision strike, intelligence gathering, and close air support. One of the defining features of the F-35A is its internal cannon. Unlike the other variants, the F-35A carries a built-in 25mm gun mounted internally above the air intake. This allows it to engage ground targets or enemy aircraft without relying solely on missiles. This reflects the Air Force's emphasis on versatility and sustained combat operations from established bases. However, the F-35A also reflects some of the compromises inherent in the Joint Strike Fighter concept. While it offers advanced stealth and sensors, it does not match the raw dogfighting performance of specialized air superiority fighters like the F-22. Instead, it relies on situational awareness and first-shot advantage. Next, the most technically challenging variant, the F-35B. The F-35B was developed for the United States Marine Corps and is capable of short takeoff and vertical landing, often referred to as STOVL. This capability allows the aircraft to operate from short runways, forward operating bases, and amphibious assault ships. In practice, it gives the Marines the ability to deploy air power from locations where traditional fighters cannot operate. Achieving this capability required some of the most complex engineering ever attempted in a fighter aircraft. The F-35B uses a unique lift system that includes a vertically mounted lift fan behind the cockpit, a swiveling rear exhaust nozzle, and roll control nozzles in the wings. During vertical landing, the engine redirects thrust downward while the lift fan provides additional vertical lift. The result is a controlled descent that allows the aircraft to land in extremely confined spaces. This capability comes with significant trade-offs. The lift system adds weight. It takes up internal space. And it reduces internal fuel capacity compared to the F-35A. As a result, the F-35B has shorter range and slightly reduced payload capacity. But for the Marine Corps, these compromises are worth it. The F-35B allows Marines to project air power independently, without relying on large air bases or aircraft carriers. It fits perfectly with their expeditionary doctrine, where flexibility and rapid deployment are critical. The F-35B is widely considered one of the most ambitious aircraft ever put into operational service. It combines stealth, advanced sensors, and vertical landing capability in a single platform, something no previous aircraft had achieved. Finally, we have the F-35C. The F-35C was designed specifically for the U.S. Navy and its aircraft carrier operations. Operating from a carrier deck places extreme demands on any aircraft. Takeoffs are assisted by catapults. Landings involve violent impacts with the deck. And space aboard a carrier is always limited. To survive in this environment, the F-35C features several key modifications. It has a larger wing area, which improves low-speed handling during carrier landings. Its wings fold upward to save space on crowded flight decks. And its landing gear is significantly reinforced to withstand the stress of carrier operations. The F-35C also has the longest wingspan of the three variants, which improves range and endurance during long naval missions. Like the F-35A, the F-35C focuses on stealthy strike missions, fleet defense, and intelligence gathering. But it must also integrate seamlessly with carrier-based operations, including coordination with other aircraft and ship-based systems. The engineering challenges of the F-35C are often overlooked. Designing a stealth aircraft that can survive repeated carrier landings while maintaining low observability is extremely difficult. Every reinforced component adds weight, and every structural change affects stealth shaping. Despite these challenges, the F-35C successfully brings fifth-generation capabilities to naval aviation. Together, these three variants tell the story of why the F-35 program exists. Rather than building three completely separate aircraft, the United States chose to develop a shared platform that could be adapted to different missions. This approach reduced duplication, improved interoperability, and allowed allied nations to adopt variants that fit their own operational needs. Of course, this also increased complexity. Design compromises were unavoidable. Engineering challenges multiplied. And development became more difficult than if each aircraft had been built independently. But the payoff is a family of aircraft that can operate together, share data seamlessly, and support one another across land, sea, and expeditionary environments. The F-35A dominates from traditional air bases. The F-35B brings stealth air power to the front lines. And the F-35C extends fifth-generation capability across the world's oceans. Each exists for a reason. Each reflects a specific mission. And together, they form one of the most versatile combat aircraft families ever created. In the next section, we'll examine the weapons systems that give the F-35 its combat punch and how it balances stealth with firepower in modern warfare. When discussing the F-35, it's easy to focus on stealth and sensors. But at the end of the day, a combat aircraft must still be able to fight. Weapons systems give the F-35 its credibility as a frontline combat platform. Not through sheer volume of firepower, but through precision, timing, and integration. The F-35 was designed around a simple idea. The right weapon, delivered at the right moment, from the right position. This philosophy shapes everything about how the aircraft carries and uses its weapons. One of the most important concepts to understand is the difference between internal and external weapons carriage. Traditional fighter jets carry most of their weapons externally, mounted under the wings or fuselage. This allows them to carry large payloads, but it comes at a cost. External weapons dramatically increase radar visibility. They turn a sleek aircraft into a collection of reflective surfaces that are easy for radar systems to detect. The F-35 takes a different approach. During stealth-critical missions, it carries its weapons internally, inside bays built into the fuselage. This preserves the aircraft's low observable profile and allows it to operate in heavily defended airspace. Internal carriage limits the number of weapons the aircraft can carry at one time. But the F-35 compensates for this by prioritizing mission effectiveness over raw quantity. Instead of overwhelming the enemy with numbers, it aims to strike key targets early, before defenses can react. This is where the F-35's air-to-air weapons come into play. In air combat, the F-35 is designed to engage opponents beyond visual range. Rather than relying on close-range dogfighting, it uses stealth and sensors to detect enemy aircraft first and engage them before they are even aware of its presence. Air-to-air missiles carried internally allow the F-35 to remain stealthy while still defending itself and friendly forces. These weapons are integrated directly into the aircraft's sensor fusion system. Targets detected by radar, infrared sensors, or even other aircraft can be engaged seamlessly. The pilot does not need to manually manage targeting details. The aircraft handles much of that workload automatically. This makes the F-35 extremely effective as both a shooter and a coordinator in aerial combat. It can fire its own weapons or provide targeting information to other aircraft in the formation. But air combat is only part of the picture. The F-35 was also designed as a precision strike aircraft. Its ability to carry precision-guided bombs internally allows it to destroy high-value ground targets while remaining difficult to detect. These weapons are guided by a combination of GPS, laser designation, and sensor input from the aircraft itself. This allows for extremely accurate strikes with minimal collateral damage. In modern warfare, this precision is critical. Conflicts are often fought in complex environments where civilian infrastructure and friendly forces are nearby. The ability to strike accurately, with confidence, is more important than sheer explosive power. The F-35's targeting systems allow it to identify targets, confirm their identity, and guide weapons with a high degree of certainty. This reduces the risk of mistakes and increases mission success. As the mission environment changes, so does the way the F-35 uses its weapons. Once enemy air defenses have been degraded, the aircraft can shift roles. In lower threat environments, it can carry weapons externally, increasing payload and flexibility. This is often referred to as beast mode. In this configuration, the F-35 sacrifices some stealth in exchange for greater firepower. This allows it to support a wider range of missions, including close air support and sustained strike operations. The ability to switch between stealthy penetration and high payload operations makes the F-35 highly adaptable. It is not locked into a single role. Another aspect of the F-35's weapons capability is its integration with Allied forces. The aircraft does not operate in isolation. It shares targeting data with other aircraft, ships, and ground units. This means that a weapon does not always have to be launched from the platform that detects the target. An F-35 might identify a threat and pass that information to another aircraft or a naval vessel, which then launches the weapon. This distributed approach increases survivability and effectiveness across the entire force. At a strategic level, the F-35 also supports nuclear deterrence. While this is not a role often discussed publicly, certain variants of the aircraft are designed to carry nuclear weapons as part of a broader deterrence strategy. This capability is treated with the highest level of security and oversight. Its inclusion reflects the aircraft's importance not just in tactical combat, but in maintaining long-term strategic balance. Crucially, the F-35's weapons systems are heavily software-driven. New weapons can be integrated through software updates rather than major hardware changes. This allows the aircraft to adapt to new threats and mission requirements over time. As weapons technology evolves, the F-35 evolves with it. This future-proofing is a key reason why the aircraft is expected to remain in service for decades. Of course, there are trade-offs. Carrying weapons internally limits payload. Operating in stealth mode requires careful mission planning. And switching to external weapons increases detection risk. But these trade-offs are intentional. The F-35 was never meant to replace every aircraft in every role. It was meant to change how air combat is approached. Rather than relying on overwhelming firepower, it emphasizes information, coordination, and precision. Weapons are tools, not the centerpiece. In many missions, the most valuable contribution of an F-35 is not the weapon it fires, but the information it provides. By shaping the battlespace and enabling other forces, it amplifies the effectiveness of the entire operation. This is why discussions about the F-35's weapons should focus on roles, not numbers. On how and when weapons are used, not how many can be carried. Because in modern warfare, success is not determined by who carries the most bombs. It is determined by who uses information most effectively. In the next section, we'll look at how these weapons systems have been used in real-world operations, and what combat experience reveals about the F-35's performance in practice. Up to this point, we've talked about what the F-35 was designed to do. Its stealth, its sensors, its weapons, its role as a flying command center. But design and theory only matter if they work in the real world. This is where operational use and combat history become critical. Because nothing validates an aircraft like combat. The F-35's transition from a controversial development program to a proven operational platform did not happen overnight. It happened gradually, through deployments, real missions, and the experiences of the pilots who flew it. The first major milestone came when the F-35 achieved initial operational capability with U.S. forces. This marked the point where the aircraft was considered ready for real-world missions, not just testing and training. Soon after, the F-35 began deploying overseas. Its early deployments focused on deterrence and presence. Simply operating in contested regions sent a clear signal to potential adversaries. But it wasn't long before the aircraft was tested in actual combat conditions. The United States was among the first to use the F-35 operationally. U.S. Air Force and Marine Corps squadrons deployed the aircraft to regions where advanced air defenses and complex threat environments were present. These missions were designed not only to strike targets, but to gather intelligence, map enemy systems, and integrate with other forces. In these roles, the F-35 quickly demonstrated its value. Pilots reported that they were able to see threats long before those threats were aware of the aircraft's presence. Enemy radar systems could be detected, identified, and tracked without alerting them. This allowed commanders to make informed decisions before any weapons were even released. In many cases, the F-35's most important contribution was information. Rather than dropping large numbers of weapons, the aircraft acted as an intelligence and coordination platform. It shared real-time data with older aircraft, ground forces, and command centers. This improved the effectiveness of the entire force. The U.S. Marine Corps, in particular, emphasized the aircraft's role in expeditionary operations. Operating from amphibious assault ships and forward bases, the F-35B demonstrated that fifth-generation capabilities were no longer limited to large airfields. This flexibility expanded the reach of modern air power. Perhaps the most widely discussed combat use of the F-35 came from Israel. Israel became the first country to publicly acknowledge combat operations using the F-35. For Israel, the aircraft was not just a technological upgrade, but a strategic necessity. Operating in one of the most complex and heavily defended regions in the world, Israel required an aircraft capable of penetrating advanced air defense networks while maintaining information superiority. Israeli F-35s, known locally as the Nadir, were reportedly used in real-world missions to strike targets and gather intelligence in highly contested airspace. While specific details remain classified, Israeli officials have consistently highlighted the aircraft's ability to operate where other platforms could not. They emphasized situational awareness as a decisive advantage. Pilots were able to detect threats, identify targets, and coordinate actions with minimal risk. Israel's experience played a major role in shifting global perceptions of the F-35. It demonstrated that the aircraft was not just operational, but effective in real combat scenarios. NATO allies soon followed. As more allied nations introduced the F-35 into their air forces, multinational exercises and deployments became increasingly common. These operations provided valuable insight into how the aircraft performed in coalition environments. The results were significant. The F-35 proved highly effective as an integration platform. It could operate alongside older fourth-generation aircraft, enhancing their effectiveness by sharing sensor data and targeting information. In exercises, Allied pilots reported that missions became easier to plan and execute when F-35s were present. Situational awareness improved. Communication became more efficient. And decision-making accelerated. This coalition capability is one of the F-35's most important strengths. Modern conflicts are rarely fought alone. They are fought with allies. The F-35 was designed with this reality in mind. Real-world missions further reinforced this advantage. In operational deployments, F-35s were used for intelligence, surveillance, and reconnaissance missions. They mapped enemy radar networks, tracked air and ground threats, and provided commanders with a clearer picture of the battle space. In many cases, these missions were conducted without the aircraft ever being detected. This ability to operate quietly, gather information, and leave without engagement represents a new form of air power. It reduces escalation while maintaining pressure and control. Perhaps the most compelling validation of the F-35 comes from the pilots who fly it. Across different countries and services, pilot feedback has been remarkably consistent. They describe unprecedented situational awareness, a dramatic reduction in workload, and a sense of confidence that comes from knowing what is happening around them at all times. Many pilots compare flying the F-35 to stepping into the future. Instead of fighting the aircraft or managing systems, they focus on tactics and decision-making. One commonly repeated observation is that pilots spend less time reacting and more time anticipating. They see threats earlier. They understand the environment better. And they are able to coordinate more effectively with other forces. This shift fundamentally changes how air combat is experienced. It also explains why, despite ongoing debate, many pilots strongly advocate for the aircraft. Operational use has also highlighted areas for improvement. Combat deployments generate real feedback, and that feedback drives upgrades. Software updates continue to refine sensor fusion, expand weapon integration, and improve reliability. This iterative process is a key part of the F-35's operational philosophy. The aircraft is not static. It evolves based on real-world experience. Over time, the F-35 has moved from being viewed as a risky experiment to a cornerstone of modern air power. Its combat history may not be defined by dramatic dogfights or large-scale bombing campaigns. Instead, it is defined by quiet effectiveness. By enabling other forces, by shaping the battle space, and by ensuring that decisions are made with better information. This is what success looks like in modern warfare. In the next section, we'll compare the F-35 to other modern fighter aircraft and examine how it stacks up against both Western and non-Western designs in today's evolving threat environment.
When people hear F-35, they often ask a question that drives endless discussions, debates, and comment sections. How does it compare to other famous fighter aircraft? Today, we're going to answer that not with dry numbers, but with real context. Generational differences. Stealth versus classic dogfighting. Information dominance. And why modern combat has changed the rules. Let's start at the top. F-35 Lightning II vs F-22 Raptor. Both aircraft are fifth-generation fighters developed by the United States, but their design philosophies could not be more different. The F-22 Raptor was built as a pure air superiority fighter optimized for speed, altitude, stealth, and dogfight dominance. The U.S. Air Force designed it to control the skies first and foremost. By contrast, the F-35 Lightning II was designed as a multi-role stealth platform capable of air-to-air combat, precision ground strike, electronic warfare, intelligence and network operations. The F-22's strengths lie in classic fighter performance, speed, supercruise, and maneuverability. It was meant to win the fight. The F-35's strengths lie in seeing first, understanding first, and coordinating first. Put another way, the F-22 aims to dominate one-on-one air combat. The F-35 aims to control the entire battlespace. In a hypothetical duel, the F-22's agility and supercruise give it an edge in close combat. But real modern air battles aren't fought like classic dogfights, they're fought at long range, supported by sensors, data links, and integrated networks. This sets up one of the biggest debates in the aviation community. Is raw dogfighting ability still king, or has information dominance replaced it? F-35 vs. F-16 Fighting Falcon.
The F-16 is a fourth-generation fighter that became popular globally because of its agility, lower cost, reliability, multi-role flexibility. For decades, it served air forces with distinction as both a fighter and a strike aircraft. But comparing a fourth-generation jet like the F-16 to a fifth-generation F-35 is like comparing a seasoned marathon runner to a runner equipped with radar, GPS, and night vision. The F-16 excels in classic performance metrics such as turning ability, acceleration, responsiveness in a visual engagement. But it was built for a world where pilots managed systems manually and relied on radar pings and visual contact to make decisions. The F-35, on the other hand, uses sensor fusion to combine inputs from radar, infrared, electronic signals, and allied platforms into one unified picture, giving the pilot unparalleled situational awareness. This doesn't mean the F-16 is obsolete or inferior in every way. It simply means it was built for a different era, one in which the aerial battlespace was simpler and less networked. Today, the F-35 doesn't need to win a dogfight, it needs to avoid one entirely by detecting threats first and engaging from beyond visual range. F-35 vs. Eurofighter Typhoon. The Eurofighter Typhoon is a highly capable 4.5 generation fighter developed by a European consortium. It is fast, agile, and excellent in air-to-air and air-to-ground roles. But unlike the F-35, the Typhoon was not designed from the outset as a stealth aircraft. Here's where the generational difference matters. The Typhoon uses speed and agility to survive and succeed. The F-35 uses stealth and information to avoid detection and strike before the enemy knows you're there. In practical terms, the Typhoon might perform well in a situation where both sides know where each other are, and stealth does not matter. But in modern air defense environments, where advanced radars and missiles can track aircraft from hundreds of kilometers, remaining undetected is often the best form of defense. This doesn't make one aircraft better than the other in every scenario. Instead, it highlights a key shift in air combat philosophy. Modern air combat isn't just about agility and weapons, it's about who detects whom first and who controls information better. F-35 vs. Su-57 Felon. Russia's Su-57 represents the Russian approach to fifth-generation design. This aircraft emphasizes high maneuverability, powerful engines, thrust vectoring, strong air-to-air performance. However, most analysts agree that its stealth design is less refined compared to U.S. fifth-generation aircraft. While the Su-57 incorporates stealth shaping, it prioritizes maneuverability and performance characteristics that potentially compromise low observable features. In contrast, the F-35 emphasizes sensor fusion, connectivity, and low observability. The Su-57 emphasizes a blend of stealth and agility with a stronger focus on air combat performance. Because of these differences, each aircraft fits a different operational philosophy. Some aviation experts describe the Su-57 as closer to a transition generation, integrating new technologies while still retaining traditional performance priorities. The F-35 represents a new paradigm: information dominance, networked warfare, and survivability over raw maneuverability. F-35 vs. J-20 Mighty Dragon. China's Chengdu J-20 is another fifth-generation stealth fighter designed with a focus on long-range interception and area denial. The J-20 emphasizes greater range, long-range missiles, strategic reach, frontal aspect stealth. Comparing the J-20 to the F-35 highlights not just technical differences, but differences in national strategy. The F-35 was designed for coalition warfare, interoperability with multiple nations, distributed decision-making. The J-20 was designed for defending national airspace, Extended reach over regional theater. Engaging adversaries before they can penetrate deeper. Both aircraft use stealth, but for different strategic purposes. Again, this comparison sparks debate because it isn't just about speed or weapons, it's about why the aircraft was built and how it is meant to be used. Generational differences, why they matter. To truly understand these comparisons, you need to grasp what differentiates generations of fighter aircraft. Fourth-generation jets, like the F-16 and Typhoon, were built in a world where radar, pilot skill, and weapons loadouts were primary. Fifth-generation jets, like the F-35, F-22, Su-57, and J-20, were built for a networked battlespace where stealth reduces detection risk. Sensor fusion creates unmatched situational awareness. Data links connect forces across land, sea, and air. Information, not just firepower, wins engagements. This shift from performance to information fundamentally changes how modern air combat is theorized and executed. Stealth versus dogfighting myths. One of the most common controversies online is the question: can the F-35 dogfight? This question usually comes from older school thinking, the belief that raw agility and speed are the ultimate measures of a fighter's worth. But dogfighting, close, visual, turning fights happens when both sides fail to detect one another earlier. Modern fighters aren't designed to wait until they see the enemy with the naked eye. Instead, they aim to detect threats at long range. Choose when and where engagements occur. Strike before being detected. Share that information with all allied platforms. In this context, stealth isn't a gimmick, it's a survival tool. And information shared through secure networks is a force multiplier. Information dominance, the new battlefield. In traditional dogfights, pilots relied on their senses, instruments, and onboard radar. Today, success often hinges on who detects threats first, who understands the battlespace best, who coordinates actions fastest, who controls the flow of data. The F-35's avionics and sensor fusion weren't additions to a basic design, they were central to its philosophy. Its goal is not to outturn an enemy aircraft, it's to outsee and outinform every other system in the sky. This is why many pilots describe flying the F-35 as fundamentally different and in many ways safer than flying previous generation fighters. As impressive as the F-35 already is, its story is far from finished. Unlike many fighter aircraft of the past, the F-35 was never designed to remain static. From the very beginning, it was built as an evolving platform, one that would grow more capable over time through software, upgrades, and integration with future technologies. This forward-looking design philosophy is key to understanding why many analysts believe the F-35 will remain relevant well into the second half of the 21st century. At the heart of this longevity is software. Traditional aircraft relied heavily on hardware upgrades. New radar? Replace the system. New weapon? Redesign major components. The F-35 approaches this differently. Its core capabilities are driven by software. Sensors, weapons integration, electronic warfare, and even flight performance can be enhanced through updates rather than physical redesigns. This allows the aircraft to adapt to new threats faster and at lower cost than previous generations. One of the most significant upgrade paths is known as Block 4 modernization. Block 4 represents a major leap in the F-35's capabilities. It is not a single upgrade, but a broad package of enhancements that touch nearly every aspect of the aircraft. These upgrades include improved sensors, expanded weapons compatibility, enhanced electronic warfare systems, and increased computing power. In practical terms, Block 4 allows the F-35 to see farther, process information faster, and engage a wider range of targets more effectively. It also prepares the aircraft to counter future air defense systems that do not yet exist. This is critical. Potential adversaries are constantly improving radar technology, missiles, and electronic warfare capabilities. An aircraft that cannot evolve quickly risks becoming obsolete. The F-35's upgrade model ensures that it stays ahead of these developments rather than reacting too late. Another major area of future growth is artificial intelligence. AI in the F-35 is not about replacing pilots. It's about assisting them. Modern combat environments generate enormous amounts of data. Sensors, communications, electronic signals, and battlefield inputs can easily overwhelm human operators. AI helps manage this complexity. Future updates will allow the F-35 to prioritize threats automatically, suggest optimal responses, and reduce pilot workload even further. This allows pilots to focus on decision-making rather than data management. In many ways, the aircraft becomes a trusted partner rather than just a machine. AI assistance also improves training and mission planning. By analyzing previous missions and simulations, the aircraft can help crews prepare for complex scenarios with greater accuracy. This kind of learning-based improvement was unimaginable in earlier generations of fighter aircraft. Another transformative concept shaping the F-35's future is drone teaming. Often referred to as manned-unmanned teaming, this approach pairs piloted aircraft with autonomous or semi-autonomous drones. In this model, the F-35 acts as a command node. It can control, coordinate, or task drones to perform specific roles, such as reconnaissance, electronic warfare, or even weapons delivery. This dramatically extends the aircraft's reach and survivability. Instead of placing a human pilot in the most dangerous position, drones can be sent ahead to gather information or draw enemy attention. The F-35 remains at the center of the network, directing the operation. This concept changes the nature of air combat. Instead of one aircraft fighting alone, future engagements may involve entire teams of connected systems working together seamlessly. The F-35's sensor fusion and data sharing capabilities make it ideally suited for this role. Longevity also depends on structural design and sustainment. The F-35 was built with long-term service in mind. Its airframe, materials, and maintenance systems are designed to support decades of operation. Continuous improvements in maintenance procedures and logistics are helping reduce costs and increase readiness across the global fleet. Because so many nations operate the F-35, upgrades and sustainment efforts benefit from shared investment and experience. Lessons learned by one operator can improve the entire program. This global user base is a unique advantage. Few aircraft in history have been supported by such a large international coalition. This ensures a steady flow of funding, innovation, and operational feedback. All of this contributes to the aircraft's expected service life. Current projections suggest that the F-35 will remain in active service into the 2070s and potentially beyond. That means the aircraft flying today will still be relevant in a world with dramatically different technologies, threats, and geopolitical realities. Of course, future aircraft will emerge. Sixth-generation concepts are already being discussed and developed. These platforms may feature even greater autonomy, new propulsion technologies, and advanced energy weapons. But the arrival of new aircraft does not mean the immediate retirement of existing ones. Instead, the F-35 is expected to operate alongside future systems, forming the backbone of air power while newer platforms take on specialized roles. In this way, the F-35 becomes a bridge between generations. It connects the era of manned fighter dominance with a future of integrated, networked, and autonomous warfare. This adaptability is perhaps its greatest strength. Critics once argued that the F-35 was too ambitious, too complex, too expensive. But complexity, when managed correctly, can be a strength. It allows an aircraft to grow rather than age. It allows a platform to remain relevant not because it is perfect today, but because it can become better tomorrow. As upgrades continue, the F-35's capabilities will expand far beyond what was envisioned during its early development. New weapons, smarter systems, deeper integration with allied forces. The aircraft will not just survive future battlefields. It will help define them. And that is the real measure of longevity. Not how long an aircraft stays in service, but how long it remains essential. As we conclude this documentary, one thing becomes clear. The F-35 is not just an aircraft. It is a long-term investment in how air power is applied, shared, and evolved. Its future is not written in metal alone, but in software, data, and collaboration. And that future stretches far beyond the present into a new era of air combat that is only just beginning. We began this documentary with a simple question. Is the F-35 worth it? It's a question that has followed this aircraft since the very beginning. A question driven by cost, controversy, and constant comparison. And after exploring its history, technology, combat use, and future, we can finally place that question in proper context. The F-35 is not perfect. No aircraft ever is. But judging the F-35 by traditional standards alone misses the bigger picture. Because the F-35 does not represent an incremental improvement over previous fighters. It represents a fundamental shift in how air combat is understood, planned, and executed. For most of aviation history, success in the air was defined by speed, altitude, and maneuverability. The pilot who could outturn, outclimb, or outfly the opponent usually won. Then came radar. Then missiles. Then networked warfare. And with each shift, the nature of air combat changed. The F-35 sits at the center of that latest transformation. It was designed not just to fight, but to see. Not just to strike, but to coordinate. Not just to survive, but to shape the entire battlespace. When people ask whether the F-35 is worth the cost, they often focus on the aircraft as an individual platform. But the real value of the F-35 lies in what it enables. It enables pilots to make decisions with better information. It enables commanders to see the battlefield more clearly. And it enables allied forces to operate as a single, connected system. In many missions, the F-35's greatest contribution isn't the weapon it fires. It's the information it provides. That shift, from platform-centric warfare to information-centric warfare, defines modern air combat. This is why the F-35 cannot be judged solely by dogfighting performance or payload capacity. Those metrics matter, but they are no longer decisive on their own. What matters now is who controls the flow of information. Who sees first? Who decides first? And who acts first? The F-35 was built for that reality. Its stealth allows it to operate where others cannot. Its sensors allow it to understand complex environments in real time. And its connectivity allows it to share that understanding instantly across air, land, and sea. This is also why debates around the F-35 are so passionate. It challenges deeply held ideas about what makes a fighter aircraft great. It replaces familiar visuals of turning dogfights with invisible battles fought through data, sensors, and networks. For some, that feels less dramatic. For others, it represents the future. Looking ahead, future air combat will likely move even further in this direction. Artificial intelligence will assist pilots. Autonomous drones will fly alongside manned aircraft. Battle spaces will become more crowded, more contested, and more complex. In that environment, aircraft that cannot adapt quickly will fall behind. The F-35's greatest strength may not be what it can do today, but what it can become tomorrow. Through software updates, new weapons integration, and evolving tactics, it is designed to grow alongside emerging threats. To remain relevant not for years, but for generations. So, is the F-35 worth it? The answer depends on how you define value. If value means raw performance in a single, isolated scenario, then the debate will continue. But if value means adaptability, information dominance, and long-term relevance in an unpredictable world, the case becomes much clearer. The F-35 represents a shift away from individual aircraft dominance toward integrated air power. A shift where victory is determined not by who flies the fastest, but by who understands the battlefield best. And that shift is likely irreversible. As air combat continues to evolve, the lessons learned from the F-35 will influence every aircraft that comes after it. Whether loved or criticized, the F-35 has already changed the conversation. And in many ways, it has changed the future. Now, I want to hear from you. If you learned something new from this documentary, give the video a like, it really helps support the channel. If you enjoy long-form military documentaries and deep dives into modern technology, consider subscribing for more content like this. And let me ask you one final question. Would you fly the F-35? Do you see it as the future of air combat, or do you think something else will take its place? Let me know your thoughts in the comments below. Your perspective is what keeps these discussions alive. Thanks for watching.